Let us solve this linear system using Gaussian elimination. We are going to come up, or we need to come up with an equivalent row echelon form of the augmented matrix for this with the application of necessary row operations. And after that, let's check for the values of the A, B, and C variables and determine whether there are results or there are infinitely many solutions, or etc. etc. So as mentioned, let us start with our augmented matrix here. So let's have 0, -2, 3, and 1 for the first row because there's no A coefficient. Second row has a 3, 6, -3, -2. Third row has 6, 6, 3, and 5. Notice here that the first entry of our first row is 0 and 3. So to make it possible for a row echelon form to happen, let us try to interchange row 1 and row 2. Okay, so it would mean it's like this now: 3, 6, -3, -2, 0, -2, 3, and 1, and we'll have the same third row: 6, 6, 3, and then 5. Then we apply necessary operations pertaining to making this as a first a leading one. So we are going to do this one here: multiply 1/3 to our row 1, all entries of our row 1, to come up with the new row 1. And also, if it's okay, let us try to make this 0 at the same time. So we are going to multiply -2 to our row 1, but not the row 1 after multiplying all entries in row 1 by 1/3. I'm pertaining to this original row 1 here, so that we could attack this concern in with two rows already. But of course, if this will make you uncomfortable, so you might try to separate this and apply the next operation on whatever matrix you're going to come up with. But of course, we are assured that no matter what we do with our augmented matrix, as long as we apply the correct operations and the correct even if in the interchanging of rows, we will end up with the same row echelon and same results or same values for our unknowns. But either way, again, I'm going to inject this one here. So -2 times 3 is -6 to make this 0. So add it to row number 3 for a new row number 3. So this would be the next process here. 3, 6, sorry, my bad. I already applied the multiplication of 1/3 to all entries in row 1. So this is 1, 2, -1, and I have here a fraction of -2/3. Okay, so the second row is 0, -2, 3, 1. By the way, I could also try to multiply row 2 immediately. Okay, let's make this with one shot as well. So let's also divide, or rather multiply -1/2 to our row 2 to make this a leading one. Okay, so yeah, we're just going to proceed with the previous set of operations. So this is 0, -2, 3, and 1. So this is now -2 times 3 is -6 plus 6, 0. -2 times 6 is -12 plus 6, so you have -6. -2 times of -3 is 6 plus 3, I have 9. And -2 times -2 is +4 plus 5, I have here 9. So just for this, in the meantime, we have achieved the 0 entries after below the leading 1. Let's make this leading 1 by, as mentioned earlier, multiplying -1/2 to all entries of row 2 to have a new row 2. And just like what happened earlier, let me also make this 0 at the same time. using the same row, not this result, but the same row here. So let us multiply negative 3 to our row 2, the row 2 for this matrix, and add it to row 3. So negative 3 times negative 2 will become positive 6 times, or rather plus negative 6, so it will become 0. Okay, you will see it later for it to become a new row 3. So apply 1, 2, negative 1, negative 2/3. For the second row, this will become 1. This will become negative 3/2. And I have here negative 1/2. Right? And then apply the necessary operations here. Negative 3 times negative 2 is positive 6. Plus negative 6, 0. This is still 0 here. Negative 3 times 3 is negative 9 plus 9, 0. Negative 3 times 1 is negative 3 plus 9. I have here 6. Okay. Now, notice here, this is actually a version of a row echelon form because this is no longer a leading one. But you may stop here because you would see this concerns here. Take note that these are all entries for our variables A, B, and C as given earlier. And all of them with 0 value will result to 6. This is not possible actually. So if you're not yet still convinced, let me come up with an equation from this augmented matrix. You have A plus 2B minus C is equal to negative 2/3. Right? So it might look possible. Yeah. For the second row, you will have B minus, minus 3 half C is equal to negative 1/2. Might be possible. But when you look at the last row, 0A plus 0B plus 0C, that's entirely 0, and it cannot be equal to 6. This is not possible. This would mean that your result or the solution for this given linear system after the application of Gaussian elimination will return to no solution. Again, no solution because you have this equation here which is mathematically incorrect. So we have verified this by the application of Gaussian elimination. Again, the result for this linear system is this linear system has no solution. Thank you for watching.